All right, let's look at the homework 11.10, problem number 7. All right, so we want to use series to approximate the value of this definite integral. All right, so let's do that. All right, so remember that, arctangent, arctangent has a power series. It goes something like this, a summation. N goes from 0 to infinity, -1 to the n, and x to the 2n plus 1 over 2n plus 1. All right, so we can write this integrand, so it's going to be an integral from 0 to 1/2. All right, so all we have to do is multiply this by x cubed. All right, so this is going to be a summation. N goes from 0 to infinity. All right, so you have -1 to the n. Then you have x to the 2n, all right, plus 1 plus 3, so 2n plus 4 over 2n plus 1. All right, then with respect to x. All right, so this is going to be, all right, so we can just have a summation. N goes from 0 to infinity. Then you have a -1 to the n, just a constant. All right, if you take the antiderivative of x to the 2n plus 4, so we're going to add 1 to the power, so x to the 2n plus 5. Then you're going to divide this guy by, so you have 2n plus 1 was already there, but we're going to divide by 2n plus 5 as well. All right, then we want to evaluate it from 0 to 1/2. Right? So plug in the upper limit, so you're going to have a summation. N goes from 0 to infinity. Right, -1 to the n. Right, then you put, now you put 1/2 here, and raise it to the 2n plus 5 over, you have 2n plus 1 times 2n plus 5. All right, then minus, if you plug in 0, so it's going to be -0. All right, so we just get that. All right, so we want to approximate this guy. All right, so we're going to do approximation. All right, so this is the alternating series. So we can see that this is going to be our Bn. So here. All right, so this is going to be our Bn. All right, remember that the error is going to be bounded by Bn plus 1. And then we want it to be accurate to 4 decimal places. All right, so I need to use a GeoGebra here, so I'm going to open up a GeoGebra. All right, so I'm going to type in Bn, so I'm going to call it the B of n, so make it like a function of n. All right, Bn is going to be 1/2, raise it to the 2n plus 5, and divided by, we have 2n plus 1, and also 2n plus 5. Then hit enter. All right, so we have Bn defined. So I'm going to just check some numbers. Let's try B1. So what's the value of B1? So B1 is B of 1. All right, so we get that. Actually, I have to change it to all right, so algebra, symbolic, so here, and rounding to maybe a 5 decimal places or something like that. All right, so you can see that B1 came out to be 0.00037. So, to get the correct to 4 decimal places, we should have at least, 4 zeros there. So this is not small enough, right? So let's change this to, let's try B2, right? So which is B of 2, right? Then you get this, right? Now you have, let's see, 1, 2, 3, 4 zeros, and this is less than 5. So B2 would be fine, which means that, let's see, Bn plus 1 is B2. So n is actually 1. So what you need to do is we want to add the first two terms, right? So we're going to do, first I'm going to say numeric, right? So that we can get the decimal expression. And the expression is going to be sum. And then you have expression is going to be, so we have -1 to the n, because it's an alternating series. And then multiply by b of n, right? Then variable is going to be n. And start value is 0. And the end value is 1. And the significant figures, we need to the 4 decimal places, so it's 4. Right, then we hit enter. Right, so we get the let's see, so we get the okay, we got that 0.00558, right? So actually 59. So I'm gonna put the let's type that in. Right, we got the 0.0059, so it's a 4 decimal places. Right, so let's submit for testing. All right, looks like we got this one correctly. All right, that's it. I hope that this was clear.